Hello, good morning. I'm Paul Merrill from Beaufort Fairmont Automated Testing Services, and today I'm here to talk about unit tests and what is a unit test. A little bit about us. Beaufort Fairmont exists to help companies solve a couple different problems. The first one is how do we sync up development and testing in agile environments? And the second is how do we automate regression tests? And we do that through three different ways. Training is one of them, so we can come in and work with your team to establish kind of the fundamentals of test automation and make sure that those are there prior to implementing a project. We can do consulting and come in and help you lay out the plan to move forward and deal with your immediate issues regarding test automation. And we can also help you staff up those types of projects, whether you want us to do the project with our team or you want us to bring in folks for your team that can help. So those are the three main ways that we work with this. We're based in Cary, North Carolina. We eat, sleep, breathe, and dream test automation. This is what we do. I'm the founder. I'm Paul Merrill, and I'm also a principal software automation engineer, principal software engineer and test, I guess it is. My Twitter handle is right here, dpaulmerrill. Hopefully you can see that on the screen. And let's get started. So let's talk about unit tests. I'm going to spend a few minutes kind of talking through at a high level what we're going to do today and kind of lay a base foundation for what we're going to talk about, and then jump into some demos and some actual code. So I'm ready for this. I hope you are as well. So make sure to mark your calendar. There's several things coming up. Today is May the 27th. I'm recording this. It was originally broadcast on the 25th, which was Thursday of last week. And so these are dates that are coming up for us. You may be looking at this in the future and saying, what in the world? So it's 2017. So back in, so June the 7th in 2017, I will be doing a presentation called What is Continuous Integration and How Does It Affect Me as a Tester? This is at the Triangle Test Automation Users Group, or TriTog as we call it, in Raleigh. It'll be hosted at Pindo downtown. Find it on meetup.com and look for Triangle Test Automation Users Group. You'll be able to find it that way. So I'm excited about that one. We've got a lot of people signed up for it. That's always a good meetup. On the 22nd, I'll be doing two events. One is the next webinar for us. So make sure to join us. Find that on our page, beaufortfairmont.com/webinars, and look for What's an API. That's the name of the next webinar. What's an API and how does it affect me as a tester? Or what's an API and how do I test them? That'll be at 1 p.m. Eastern Daylight Savings Time. Online, come right back here and you can find us. And then also there's a Scaled Agile Framework meetup in Cary, which I'll be speaking at, about methods for testing in agile environments and how to get automation going and working within automation environments. So make sure to join us for that. An agenda for today. We want to talk about why we do test automation, specifically why do we do unit tests, why do we create them, what are they for, who is it that creates unit tests, and then how do we create them? That'll be the demo part. So I'm going to kind of race through this initial part here. Why? So why do we do unit testing? Unit tests were originally developed by developers, and they were intended to ensure that whatever code the developer was working on would work not only then, it would work with a set of test cases. It was automated, but it was to try to provide very fast feedback. So we want to exercise the code that we're working on. There are people out there who can create code, write code, and not execute it and understand that it works perfectly. The large majority of us that do development cannot do that. We need to exercise the code in order to see how it works. And so unit tests were built in order for us to take a very small piece of code, a method within a class, a few methods within a class, and exercise that and test our assumptions about it. Those assumptions might be what the intention of the functionality is, and we may assert that that functionality works as we expected. So we want very fast feedback. We want to test very small pieces of code. We're not going to block on things. We're not going to call into third-party applications or APIs or anything else. We're not going to call into a database. We're not going to call into the file system. In most cases with unit tests, we're working with a very small piece of code, a method, a subroutine, a function, whatever you want to call them. That's what we want to look at, as very small pieces of code. There are two kind of classes, or two different types of unit tester. There are people who are the classicists, which believe that we're going to write a test case for what we need today. It's okay if it calls into different methods. It's okay if it calls into different classes as long as we're able to learn what we're working on. And it's okay to have a certain set of dependencies. So those are classicists. We also have the idea of mockists, and I tend to be more in that camp of unit testers. And these are folks who believe that we take one particular piece of code and we mock out everything around it so that there are no dependencies involved in our unit test. And it makes it so that it's easier to run unit tests over time. It makes it so that we have very clear delineations between our classes and with our tests and all of that. So those are two different kind of sets, but unit tests in general run very fast. I'm going to show you how fast they run. They run in seconds or just very small fractions of seconds. So we may have many unit tests, hundreds or thousands of unit tests for a particular set of methods or a particular class or a particular chunk of code, whether that's a service or a microservice or whatever it is, an embedded system, whatever. So we're talking about very small things here. Another reason for writing unit tests is confidence. So we want to know what our code does at any point in time. If our code is doing something different than what we expect, we want to know that. We want to be able to count on a unit test in order to tell us that it works as we expected or not. So we want to have a high level of confidence, and unit tests can help us as developers create that level of confidence. We want lower costs to debug. We want lower costs to find and fix defects. When we have unit tests in place and we're not depending on some third party to test our code, and we can run things in an automated, very fast exercise or execution, the cost of fixing a bug, the cost of finding a bug, the cost of debugging a problem goes down. So consider for a moment the idea that the way that we used to work through code, and a lot of people still do this, but if you're writing code and 6 months later you are assigned a defect that was just found, you've got 6 months worth of other things since you worked on that piece of code to throw out of your brain, and then you've got to go back and focus on that one piece of code that you wrote back then. And for most developers, I believe, for myself especially, if I look at code that I wrote 6 months ago, it's a lot like looking at somebody else's code. It's a lot like looking at something I've never seen before. So in those cases, I have to go back and think through exactly what I was doing at the time, try to understand why I wrote it the way that I did, try to understand what the problems may be, caching up the entire set of use cases associated with it, whatever. If, on the other hand, I have a unit test that I've created while I'm developing the code, I can tell right away how it works in particular situations. So that's why we want unit tests, to try to narrow the gap between when we get our feedback from the code and when we write the code. And the smaller that gap gets, the lower cost it is to deal with things, the easier it is to fix problems. These are very much technical facing type of tests. So I want to talk about that a little bit. This is straight from Lisa Crispin and Janet Gregory's book, Agile Testing. They borrowed it from Paul Merrill, who created it back in, I believe, 2003. I've got references to these in my slides, which I will share with you later, and you're always welcome to reach out to me with those types of questions. Hey, can I have the slides, Paul? Sure, paul@beaufortfairmont.com. Or you can reach out to me on Twitter, Paul Merrill on Twitter. Anything that you see while you're watching this recording that you want to tweet, I'm always open to that. I love seeing that kind of stuff out on Twitter. Just reference me, Paul Merrill, or reference the company, Beaufort Fairmont, on Twitter. But this diagram does a great job, I think, of breaking down different types of test cases and showing them in certain categories. So on the left side, in quadrant 1 and 2, we see automated and manual tests, but at the bottom left we see unit tests and component tests. And we see this writing over on the left that these are supporting the team, and then down at the bottom that these are technology facing. So it's very rare that a business user would see a unit test. It's very rare that a customer would have any impact on a unit test or be impacted by a unit test. I'm not quite sure how to talk through that, so I may have described that poorly. But usually unit tests are used by people that are in the technical group. So they're written by developers generally. Sometimes they're written by testers, but that's pretty rare. I believe very strongly that developers should be writing unit tests. There are some cases when you would want testers or other people in the business involved in unit tests, One of those might be if you've got someone who's learning to code from the testing org and you want them involved with developers. Well, that's a great time to have them involved in learning about unit tests, and that may open up their mind to how to write code at a higher level, whether it's integration tests or service tests or UI tests, any of those. There are other times when, hey, maybe a developer needs a little bit of exposure to the way that a tester thinks. So maybe we pair up a tester with a developer and kind of blur the lines there. And I'm using the word blur the lines directly from Marit's recent post back in, it's May of 2017 once again. But Marit Pohjovarvi, I got her name wrong, but Marit out in Finland does a really great job on her blog talking through these types of things. And she had a really good post about blurring the lines between developers and testers. And that was the exact situation, was a tester sitting down and talking through what unit tests one might want to consider when developing their code. But I thought that this was a really handy diagram to kind of get us in the spot of understanding what it is that unit tests do and how they face us, how we work with them. So quickly, who is it that creates these? I talked a little bit about this. Usually it's developers. Every once in a while you see DBAs. I heard of a person recently, a client that was working on some code and they wrote unit tests around the database. And you can definitely write unit tests for database for things like triggers and stored procedures and whatever else. So that's what that individual was doing. Testers, every once in a while, I named a few cases where testers might want to be involved in unit testing. Our company, Beaufort Fairmont, we usually don't get into unit testing. We do sometimes. Usually that's when we're trying to understand a piece of code, when we've got a legacy piece of code that we want to understand better, and we need to create unit tests in order to see what it actually does today. So there are lots of reasons to create unit tests. Some are about developers and them looking at their design critically and understanding the intent behind the use case and determining whether or not that's in line with the execution of the code. But sometimes there are other reasons as well, understanding what the code actually does today, showing what it actually does today as opposed to what we think it does. So there are lots of different cases for that. Maybe exploring the code. You can explore the code with unit tests. So I think that's another thing to do as well, and I think that's a testing activity. How? So how do we do that? Well, let's find out. Let's get into this code. So what I'm going to do now is I'm going to switch the screens on you, and hopefully you've been seeing my presentation here. Sometimes this takes just a second to switch over, so bear with me if it's taking just a minute here on your screen. Hopefully not, and hopefully you can see all this. What I'm doing here is I've got Eclipse. Hopefully you're seeing Eclipse, and my apologies if the resolution is a little bit low for you. I've tried to scale up the fonts a little bit so that you can see a little bit better. What I wanted to do was to take a very simple example and work through this with you guys. So this example is about the idea of a palindrome, and this is one example that you'll see again and again in interviews, but a palindrome may look something like this, right? So it's a string that reads the same forwards as back, so ABA would be a good one. Someone in the live presentation of this webinar said race car, and that is a good one. Race car, so it's spelled the same frontwards and backwards. We can look at simple strings like 111, that's obviously spelled the same forwards back. 121, that would be another one. Lots and lots of examples out there, but those are a few for you. So this is what a palindrome looks like. What is a palindrome? And since you're watching a recording, if you need to take a minute and look up what they are, that's fine. What I've got here is I'm using Eclipse, that's the application that I'm in right now. I'm using the language Java, the programming language Java. And I've created a unit test. So this palindrome test is a suite of unit tests. And what I'm doing is looking at this class called palindrome. That's my code under test. My class under test here is called palindrome. I've created an instance of it. I use a setup method here. JUnit in Java provides setup and teardown methods, which are really nice. And I'm just making sure that I've got a clean instance of this class every single time that I start up. That's something that I like to do just to make sure that I clean up. And you can see the very first test here is very simple. It's one line long. It's called test simple palindrome. And apparently what this developer wanted to do, which by the way, the developer is me, so this is what I wanted to do. They wanted to start with a very, very simple test case. So they looked at the string A. Now we know that A spelled forward and backwards is exactly the same thing. So they've gone in and they've called this method called isPalindrome on the object palindrome. So isPalindrome. So they're asking, is this a palindrome? And as we all know, we should return true. So they've asserted what we believe should be true. So they've asserted that it should return true for the string A. So we can run this very simply. Here in Eclipse, I can just do a run as. And by the way, all of this is available on my GitHub site. So my username on GitHub is dpm3354, and the palindrome code base is out there. You can find that very easily, and you'll be given exactly what we've got here to start out with. So we ran that test case, and you see this nice green bar down here. That means that it passed. So this is a little interface that is built into Eclipse to show us whether or not a test case runs. And we see that we had 1 out of 1 test run. We've got 0 errors, 0 failures. You can look specifically at the test here and see it. We see that there are more tests here. So the second test here tests the string AA, and we know that that should be true. So if we run that, we can see that it passes. We know that the string 11, so apparently this developer says, okay, I've tried a couple different things. I've tried a single character with this. I've tried 2 characters. I want to try 2 numeric characters. So let's run 11 as a possible palindrome, and we asserted that it was true, and it passed, so that means that we returned that it's true. And then they get a little trickier. They're going to try a 3-character string with different types of characters. So we're no longer just AAA or BBB. We've got BAB, and we know that that should be a palindrome. Let's run it, and it is, as we would expect. And then there's one more case. They do a negative test case, so this is great. So a lot of times we as developers, when we're writing code, and I believe I'm a tester and a developer. I like both of those 2 roles. But a lot of times when we test things, we only think of the positive test cases, the happy paths. This developer thought of one negative test case, and that negative test case is BA, and he wants to make sure that it is that results in a false. And once again, I say he because I'm the one who did this. It's not an exclusive type he there. So B, that passes as well. So we've run through all of these. Now, it doesn't have to be that slow. We can just click on this and run all of these unit tests. You see the 5 ran very quickly. And one thing you'll notice here as well is that these ran very, very quickly. So less than 1/1000th of a second. And each of these doesn't even round up to 1/1000th of a second. I have a feeling that they just have a baseline of 0.001 for any run here. It ran very, very fast. And that's what we want to see out of unit tests. So a lot of you may be thinking, hey, look, this is clearly not a comprehensive suite of tests. And you're right. You're absolutely right. Hopefully, you're taking a moment here and you're thinking about what are some other cases that we could test. What are some other cases that we could test? Well, let's just take one that we already wrote. Let's just do race car, okay? Let me do this. And we know that race car is a palindrome, so I'm going to add it in here, okay? Race car, and we're going to do it here, race car. Great, let's see if this works. And we know that that should result in true. Let's run this. And it did work, okay? So race car worked. Let's try something a little more tricky. Let's try, I want to try a different case here. I want to try a negative test case with more than 2 letters. Let's just see what this does, because they only did one test case, one negative test case, and this just doesn't look right to me. Let's see what happens. Okay, so that passed. Let's try something else here. Let's try something a little more complicated where we have a negative test case with something like this on the inside of it, okay? So let's try this. We know that this should not be a palindrome. And let's just check to see if it runs. So basically this check is checking, hey, did we check any of the inside of that string there? Because I don't see them testing this anywhere. So let's just run this. And look at that, we got a red bar. So that means we found our first failure. And this is kind of one of the patterns in tests testing unit tests. Test-driven development affords you the opportunity to go in and create unit tests and then go in and create the code behind it. And in that case, that's exactly what I'm going to do. So I'm sure a bunch of you were saying, hey, look, I want to see what's going on in this method. Tell me what the problems are in there. Let's drill down into it. So that's what I'm going to do. And right away, we come in here and we see this method. And it looks like there are several problems to me. Now, I'm familiar with this, so it might be very easy for me to look at this. For you all, it might be different depending on your level of experience or familiarity with Java or any of that. But this is a very, very simple class, and what it is just a method that returns a Boolean, which is true or false. It takes in a string, and then it compares, it's supposed to compare the string to the string backwards. And it appears to me that it doesn't do that at all. Instead, what it does is it's comparing, and hopefully you guys got this as well, but it's comparing the first character in the string to the last character in the string. And now we understand exactly why we got the result with the test that we had and why so many of these passed already. None of these strings are doing a negative test case where the exterior parts of the string are the same, but the interior are different, okay, except for this new one. So I very much have been in position to see developers do something like this. Okay, so what I did, some of you see it right away, but some of you don't. So I have seen this happen many, or maybe not many times, but a number of times. And if we go back and run our test here, oh, wait a minute. Yeah, sorry, I ran all of them. That's not what I wanted to do. But if I run this one specific test, it passes. We get a green bar. So the new test case that we wrote is now fixed. The old test cases, if we run through them, so there's another one, some of them seem to be fixed. If we run through all of these, though, we have a problem. And the problem is that when we have a short letter or a short string, we get a string index out of bounds exception. And what it's saying basically is if you put a single character string in here, then you're going to be out of bounds when you try to look at the second character in the string, right? It's only got one character in it, so if you try to look past that, you're going to have a problem. We can't do that. But I've very much seen this type of solution written up and gotten to the point with somebody where, okay, so listen, I tried a character that was 4 strings, and they'll do something like this and make a pass, and then I say, well, okay, I've seen your commit on Git, and it's not a very robust solution in my mind, so let me show you that this doesn't work with 6 characters, and then they would add a third on here, and eventually it was just ludicrous, but I have definitely seen folks do that type of solution. And I think a lot of times developers say, why in the world would you test a 4-character string or a 6-character string or an 8-character string or a 7-character string? I know that I took care of all those cases, but it's solutions like this by developers who are not as who do not create robust solutions that have us testers doing that. So a more robust way to do this, and this is one that someone pointed out in the live version of this, and I thought it was good, so I'm going to steal it. But they basically used a reverse function and returned the result of that. And I thought that was very nice. So this is a little bit too much Java-y for some people, I'm sure, but it's easier for others. So a string builder has a really nice function on it called reverse, and it will reverse the string, and then they did toString to get it back into the same format, the same class rather, as the string that we pass in. So this should tell us whether or not forwards and backwards we are equal. So let's run this and see if that solution works. Nice, it worked, okay? So that's good. Now you can go a lot farther with this, and on the live webinar, some people came up with some really good ideas here, okay? So there was one individual says, and this is why you really shouldn't miss the live ones too, because people are just so terrific to come up with ideas. So they said, what about an empty string? I said, that's a great idea. So we did, what should an empty string be? I don't know how an empty string is defined. But let's see what it is. Let's just assume that it should be false, okay? That an empty string is not a palindrome. I'm not sure what the pure definition on that is, but in our application, that's the way that we're going to define it. That if you pass in an empty string, we should get back false, okay? So let's run this guy, see if an empty string works. Oh, and it did not work, and we got an assertion failure. So apparently we had an issue with that. They believe that reverse is the same, but we've decided that it should not be a palindrome. Sorry. Apparently the implementation of the reverse function from string builder believes, well, I guess it returns an empty string, and so the equals works there, right? But we wanted to find something different. So let's just add in, if the string is empty, then return false, okay? So if it's empty, we're going to say false. And so this is a place where we start looking at implementation. And there are different ways that different folks implement things, different ways that they write code, and I completely understand that everybody is different on this kind of thing. You see me making a very simple change here, okay? I did not go in and try to solve every single case. I just very quickly returned false and hard-coded this in. And a lot of developers are going to say, hey, look, you've got two places where you're returning from that function, and there are best practices out there that suggest that you should never do that. Never is a very long time in my mind. There are places where multiple returns make things more clear and things where it doesn't. So I would ask you for some tolerance on that particular view if you have it. But there's always time to come back and do this, okay? So you could save off a temporary variable and use it to return at the end. That's certainly true. And if that refactoring makes sense to you, you should definitely do it. I kind of come from the school of test-driven development, so that would be something that I would do now, so I could go back and refactor very easily. So let's just assume that that's something that we wanted, is to have only one return so let's fix this and refactor. We know that we can refactor very easily here because we've got all our tests in place, which is really nice, okay? So I don't really have to think a whole lot about this. I can just kind of put it together. Maybe I've made a mistake, I don't know. Let's just run the test and find out. Nope, I made a mistake somewhere, so let's see what I did here. Well, let's think through it now. Okay, so if this is, oh, here we go, is palindrome, is not saved, so now it is. Now let's see if that works. Let's see if I got this right. Run as unit test, everything passes again, so we're back to a good state. Somebody else said, hey, what about null, okay? And so I coded that up, and you know, we can go through these all day and have lots of different cases. Somebody came up with uppercase versus lowercase. That was a cool one. I'm going to say that null results in a false as well, and really this would be if it's not empty and if it's not, if string is not equal to null, or that. See if this works. Once again, not sure if I've done that right. I don't really care because I've got all my tests here. They're going to tell me if I got it right. And then I can think about it later if I have to. So clearly I did not. Let's see, there's a null pointer exception. So why is that? if string is not equal to if string is not equal to null, then associate that. Or okay, so if it's null, then what happens? I guess I've got this wrong. And of course, doing this in front of people is always more difficult. So it looks like this is an and. Just takes me just a second here to get my bearings. Even on a recording, it's more difficult. I don't know how that works because you guys aren't even there right now. You're there later. But there we go. So I just needed to think through my logic just a bit. But you can see how the tests are helping me. They're assisting me in what I have to think through and what I have to be concerned about. And I can move forward in the code very quickly. A lot of my knowledge on this comes from Kent Beck's book, his terrific book, TDD by Example, Test-Driven Development by Example. That was written in Java back in the late 90s and early 2000s. Hopefully this gives you a little bit of an idea about what a unit test is and how it works. These are extremely low level. You notice how quickly we can write unit tests once we've got a wrapper around it. With greenfield development, that tends to be the case. It's very quick to write them. If you're getting into legacy code, you need more information in order to deal with things. And I would suggest Michael Feather's great book about legacy code and dealing with existing code. I think I have it right here somewhere. Trying to remember the exact name for it, but look up Michael Feathers and legacy code and you'll find it. Terrific book on how you separate out dependencies in legacy code in order to wrap tests around it, and the systems that we use to do that carefully, and how we can deal with legacy code. That's a much bigger problem than people tend to be aware. So once again, all this is out in its original state on GitHub. I'm not going to post any changes to it, so that it's out there broken, and you can fix it on your own so that you can learn about this. I don't believe I have the Eclipse project out there, so you'll have to bring it into whatever your IDE is. But that's that. So thank you so much for joining me. I want to switch screens again here really quick. And hopefully I'm showing you the screen that I mean to be showing you now. Sometimes that takes just a minute. We were looking at these slides here. I had one more here. These are my references. Once again, the code base is at dpm3354 on GitHub/palindrome. I used a number of different books to look through this. The biggest pieces were these two posts, one by Lisa Crispin, and it's also in hers and Janet Gregory's book, Agile Testing, which is a terrific book. Brian Merrick was one of the first to think of this, and his, what I believe is the original diagram for this, is back from 2003, and this is the link for that. And then, of course, continuous delivery references, this on page 84 as well. Look, this is what we do at Beaufort Fairmont. This is what I do with my career and with my working time, it's helping people with test automation. If you have challenges, I want to talk through them. I like to get to know people on these recordings, people in our webinars. I like to figure out what's going on in your environment. It helps me take that information back to other clients in a very everything's always confidential, of course, but in a non-threatening way or whatever. I don't know how to say that, but I try to be very secure with everybody's information. And I like to learn about your challenges, take it back to other people so that it can help them. I like to bring it into the next show of these, the next webinar, and help. I speak a lot out on the testing speaking circuit in the United States. I'll be out at Star West this year. I'll be at Agile 2017 this year in August. I'll be at Star Canada in October, and STP in September. So I like to get out and share information that I learned from you all. I also like to help people a lot. So I always do a 1 hour free talk through your challenges. That's kind of the way that we do things. This is our number right here. So call us. That's a US number. Office hours. So I'm offering a new offering called Office Hours. It's $500 a month. We spend an hour a week. We set up a specific hour, 2 o'clock or 3 o'clock on Friday or Thursday or whatever it is that we agree to, for $500 a month. And whatever you want to discuss during those calls related to test automation or testing, you can use my experience, my time, my mistakes to your advantage, my failures and my successes, all of that, whether it's about UI testing or unit testing or integration testing. We've done all those. I'm always happy to set that up and get people going on that. It's very low risk. If you aren't impressed, if you don't get what you want out of it, you can have your money back. So there's no risk involved in that. Our webinars, you can find them all, beaufortfairmont.com/webinars. My email address is here, paul@beaufortfairmont.com. Make sure to reach out to me on Twitter. I want to get to know you folks. Find me on LinkedIn. I believe I'm Paul Merrill on LinkedIn, and connect with me there. I like to get to know people. I want to hear about your challenges, and I want to help. So once again, thank you so much for your time. I appreciate you spending your time with me. Get signed up for our webinars. You can do that on the webinars page there as well. And I just really appreciate you being here. I hope you learned something. Make sure to give me feedback, and I'll talk to you next time. Thanks.